Adler-32 is a checksum algorithm which was invented by Mark Adler in 1995, and is a modification of the Fletcher checksum. Compared to a cyclic redundancy check of the same length, it trades reliability for speed, preferring the latter. Adler-32 is more reliable than Fletcher 16, and slightly less reliable than Fletcher 32. History. The Adler-32 checksum is part of the widely used zlib compression library, as both were developed by Mark Adler. A rolling checksum version of Adler-32 is used in the rsync utility. The algorithm. An Adler-32 checksum is obtained by calculating two 16-bit checksums A and B and concatenating their bits into a 32-bit integer. A is the sum of all bytes in the stream plus 1, and B is the sum of the individual values of A from each step. At the beginning of an Adler-32 run, A is initialized to 1, B to 0. The sums are done modulo 65,521. The largest prime number smaller than 216. The bytes are stored in network order. Big endian. B occupying the two most significant bytes. The function may be expressed as A equals 1 plus D1 plus D2 plus Dn, mod 65,521. B equals 1 plus D1 plus 1 plus D1 plus D2 plus 1 plus D1 plus D2 plus Dn. Mod 65,521 equals n times d1 plus n minus 1 times d2 plus n minus 2 times d3 plus dn plus n. Mod 65,521. Adler-32. D equals b times 65,536 plus a, where D is the string of bytes for which the checksum is to be calculated, and N is the length of D. Example. The Adler-32 sum of the ASCII string, Wikipedia, would be calculated as follows. A equals 920 equals 398 hex. Base 16. B equals 4582 equals 11E6 hex. Output equals 4,582 times 65,536 plus 920 equals 300,286,872 equals 11E60398 hex. The modulo operation had no effect in this example, since none of the values reached 65,521. Comparison with the Fletcher checksum. The first difference between the two algorithms is that Adler-32 sums are calculated modulo a prime number, whereas Fletcher sums are calculated modulo 24-1, 28-1, or 216-1, depending on the number of bits used, which are all composite numbers. Using a prime number makes it possible for Adler-32 to catch differences in certain combinations of bytes that Fletcher is unable to detect. The second difference, which has the largest effect on the speed of the algorithm, is that the Adler sums are computed over 8-bit bytes rather than 16-bit words, resulting in twice the number of loop iterations. This results in the Adler-32 checksum taking between 1.5 to 2 times as long as Fletcher's checksum for 16-bit word-aligned data. For byte-aligned data, Adler-32 is faster than a properly implemented Fletcher's checksum, e.g., one found in the hierarchical data format. Example implementation. In C, an inefficient but straightforward implementation is. See the zlib source code for a more efficient implementation that requires a fetch and 2 additions per byte, with the modulo operations deferred with 2 remainders computed every several thousand bytes. Advantages and disadvantages. Like the standard -32 Costa Rican colones, the Adler-32 checksum can be forged easily and is therefore unsafe for protecting against intentional modification. It's faster than -32 Costa Rican colons on many platforms. Adler-32 has a weakness for short messages with few hundred bytes, because the checksums for these messages have a poor coverage of the 32 available bits. Weakness. Adler-32 is weak for short messages because the sum 8 does not wrap. The maximum sum of a 128-byte message is 32,640, which is below the value 65,521 used by the modulo operation, meaning that roughly half of the output space is unused, and the distribution within the used part is non-uniform. An extended explanation can be found in RFC 3309. Which mandates the use of CRC32C instead of Adler-32 for SCTP. The Stream Control Transmission Protocol. Adler-32 has also been shown to be weak for small incremental changes, and also weak for strings generated from a common prefix in consecutive numbers, like auto-generated label names by typical code generators. See also List of hash functions. Notes. RFC 1950 specification contains example C code. Zlib implements the Adler-32 checksum in Adler-32. C. RFC 3309 information about the short message weakness and related change to SCTP.